My name is Mahesh Krishnan. I work as CTO at a company called HealthConnex. It's a Telstra health company. It's based out of Melbourne. I've been working on Azure for a number of years now, and I'm also an Azure MVP. The title for today's talk is Creating Highly Available and Resilient Microservices on Microsoft's Azure Service Fabric. It's a bit of a mouthful. It's a pretty big topic. But if you're going to tweet about it, you can actually use this hashtag over here, hashtag CLD334. You can also follow me on Twitter. And my handle is Mahesh Krishnan, one word. So you can do that as well. The agenda is roughly as follows. We'll firstly talk about microservices, and more importantly, why we need microservices. And then I'll give you a bit of an intro into the Azure Services Fabric platform itself. So did any of you go to Mick's talk yesterday? Okay, a few people. There's probably a bit of an overlap from his in content from his talk, but I'll be sticking more towards the actor framework in my talk. I'll also talk about different programming models that are available in the Service Fabric, that lets you write all these wonderful microservices. Particularly, we'll be talking about reliable actors and reliable services. And then we'll finish up at the end, but there'll be plenty of demos and code that you can actually look at before I wrap up. Before we move on to microservices itself, let us talk about how we've been writing applications in the past. We write big, large, monolithic applications. I know I've been involved with several of them. And one of the things about these monolithic applications is they typically run in a single process. And yeah, sure, they're probably broken down into a bunch of libraries and so on, and you try to layer it down and all those kind of things, but it's still one big application. And you need to deploy it as such as well. So when you deploy them, or even before you deploy them, there's a lot of work that needs to go into it. There's a lot of testing. The delivery cadence of this is usually pretty low in a year. So you probably deploy maybe about once a year or twice a year. If you're lucky, you'd probably do a lot better than that. But the reason it takes a long time is because it's a big, large application, and people insist that you need to do a lot of regression testing and everything else as well. And there are a number of, if you want to scale this application, you put it up in a box, and you can actually scale up, put it in a bigger box, and you kind of get some amount of scalability. You can also scale it out, run it on multiple servers, and you get some scalability as well. But still there are a number of problems. First and foremost, these apps are typically big and bulky, and by nature when they've developed, they've got a lot of interdependencies, and it kind of has a lot of tight coupling within itself. I already mentioned about the delivery cadence, and although you may break your team itself into much smaller teams so they can actually work on it, one of the things that you'll actually find is that the team needs to kind of know the entire application itself. They need to have a much wider understanding on the application, and you're effectively tied down to a single technology stack for the application. If you wanted to write a small bit in, let's say, Node.js, it becomes really hard. Everything got stuck in the same technology stack as well. Enter microservices. Microservices, on the other hand, are small services that are actually, you implement smaller services that expose much smaller functionality as well. You can think of these monolithic applications broken down into vertical pieces. So if you've got a big monolithic application, you break it down vertically, and then you can actually deploy them as microservices. And because they're much smaller, it's a lot more easier to deploy them and scale them independently as well. If one microservice needs to be scaled up because it gets a lot of traffic, you can quite easily do that. So let's go and see why we need microservices. One of the biggest reasons is that it addresses a lot of problems that we actually spoke about with the monolithic applications. First and foremost, as I said, they're pretty small, so they can actually be developed and deployed pretty quickly. You get to have faster delivery of your services, so your time to market and everything is pretty low compared to your monolithic applications. They can be independently versioned as well and deployed and scaled, all of those things. And because they're small, you can have a much more smaller team, much more smaller focused team that can actually work on the microservice. And they can use any technology of their choice. When they're working on that, maybe they can use Node for one service, and they can use .NET and C# for another one, and you're not impacted by that. So it gives you a lot more flexibility around it. It also improves things like fault isolation because of the loose coupling that that is part of the whole design of microservices. Now, you can go ahead and deploy, write microservices in the current platform on Azure right now. But then there's a new PaaS offering that Microsoft have actually come out with. And that allows you to make use of, it's effectively a new platform as a service offering that allows you to write microservices quite easily. And that platform is your Microsoft Azure Service Fabric. I'll just be saying Service Fabric for short, if you don't mind. Microsoft actually defines it as a platform for reliable, hyperscale, microservice-based applications. I effectively think of it as nothing more than PaaS v Next. It's the next version, or next generation of PaaS itself. So what it does is that the Fabric takes care of a number of things for you, things like availability and load balancing and replication and failover, scalability, even things like data partitioning. All of those things is taken care of by the platform and the Service Fabric. What you do is you write microservices that sit on top of it and make use of all those cross-cutting concerns. The other thing that I want to point out is that you can actually run it on Azure. You can run it on Azure. You can also run it in your own private cloud. And if you so choose to run it on any other cloud provider, you should be able to do that as well. So it's effectively nothing more than an abstraction layer over which you can run all your microservices. And the microservice actually runs in what is known as a Service Fabric cluster. The Service Fabric cluster consists of many nodes. You can think of each and every one of those nodes as a virtual machine or a VM itself. And you can run you can run thousands of these nodes. And the other thing is that so you can run thousands of these nodes in the cloud and make use of all the scalability and everything else. And you can also run the same thing on your machine. So obviously you will not be running thousands of those nodes in your machine, but you could run a subset of them. And it's effectively the same piece of software that runs on Azure that you run on your machine. So it's not some kind of an emulator or anything. So you'd be able to see and test exactly what you see on the cloud. So when you write your application, when you write your microservices, you can actually put a whole bunch of these services into one application, and you can deploy them. So you could effectively have more than one application, all with its own set of services, and then you can actually deploy it onto the Service Fabric cluster. When you deploy them, what the Service Fabric cluster does is it picks out each and every one of these services and appropriately places them in each and every one of those nodes. So it looks at it and says, depending on the availability and the resource availability and so on and so forth, it actually places them within the cluster of nodes. Now you do have you can actually set your preferences and say, I want certain things, and the cluster will take care of those things. What happens is one of those things goes down, one of those nodes actually dies, one of the VMs actually dies. The Service Fabric will automatically take the services out and repartition and put them in the other nodes appropriately. So you don't have to worry about it. So now you notice that within that, what I actually showed you, the whole bunch of things that actually come. We looked at availability. So you have multiple nodes, and so you can run your application across all these nodes. You have things like disaster recovery. When one of these things actually blows away, you'd be able to repartition and run those things in other nodes. Now, if you compare this with things like the cloud services that is in operation today, cloud services typically, you write them either as your web roles or your worker roles right now. And if you're running a worker role, each and every worker role will typically run in in a virtual machine by itself. So when you deploy it, it runs in a VM. So if you've got about 10 worker roles, you create about 10 VMs to run it. Whereas with something like this, you could run multiple applications, which consider, let's say you can run about 10 applications within 5 nodes, or you can run thousands of them in about 10 nodes or whatever it is. So you have this high deployment density, and it does offer you things like cost savings and things like that compared to your cloud service. So let's dig in a little bit into microservice itself. Now there are two types of microservices. One is effectively your stateless microservice, and the other one is your stateful microservice. So if you look at the stateless microservice, it is effectively the kind of microservices that we write today in any environment. It doesn't have state, as simple as that. If it needs to hold state, it will persist it to an external storage. Could be anything. Could be Azure database. It could be table storage, whatever it may be. Right? It can persist it externally. If you make a request to the service and it needs information to that state, it will go in, read the data from it, perform its action, and then get rid of that, or save the state back into the storage. Now, because it doesn't hold any state, you can actually run multiple instances of it quite easily, and you have high availability. If one of those services actually goes down, you can make a call to another service, and because there's no concept of state held within that microservice, within that service, you can go reload the state from the external storage, and everything just works fine. I mean, existing applications like typically ASP.NET or Cloud Service and all that use this model. But then what this does is it adds all this extra complexity on your part where you need to persist state and handle all those things. So what the stateful microservice does is exactly that. It handles the storage of the state for you internally. So when you want the state to be stored in it, it persists it in local storage within that VM. Now, you must be thinking, hey, what happens? You said it actually stores in the local storage. What happens if that node actually goes away? Some hardware failure and the node actually fails. What happens to my state? Now, this is where the replication comes into play. So Service Fabric will automatically replicate this state across multiple nodes within the cluster so that even if the one node completely blows away, then the other node can actually take over and you have access to that state. Now, because it's actually stored locally, latency is pretty low as well. So everything is actually quick. You don't have to go over to some other machine externally to get access to that state. Now, I'll actually talk about it later. You can also completely get rid of storing it to the local storage in some cases and just hold it in memory. So I'll talk about that a little bit later. It also does a whole bunch of things like partitioning for scale purposes. So if you've got a lot of data and you want to, we talk about scalability of data itself. You'll be able to partition your data based on, let's say, if you have a directory, for example, you may say, I want to partition the data based on the first letter of the last name or something like that. So you may be able to spread your load across all these multiple nodes. So how do you go about programming this? Let's go over to cutting code, I suppose. There are two APIs that Microsoft actually exposed for us to use in the SDK. One is called the Reliable Actors API, and the other one is the Reliable Services API. Like I said earlier, I'll be covering a little bit more. I'll spend a little bit more time on the Reliable Actors API, and we'll have a lot more demos on it. And I'll also quickly touch upon the Reliable Services API. So let's go to the Reliable Actors. Now, the Reliable Actors API is actually based on this thing called the actor programming model. Now, this is not something new. This is originally, there's a guy called Carl Hewitt who actually came up with this in 1973. If I look around the room, there are probably some people who weren't born at the time. So, it is actually pretty old. which also means that it's actually pretty mature in terms of, it's been around in the industry for a pretty long time. And there are a lot of implementations of the actor model in other languages like Erlang and so on. And I gave a talk a couple of years ago, it was probably last year at TechEd in New Zealand. It was based around Orleans, which is also makes heavy use of the actor framework or actor programming model. Now, to explain the actor programming model, it's very simple. The actor is based upon this this concept of the fundamental unit of computation is called an actor. So what is that unit of computation? The unit of computation does about three things. One is it does some processing. It holds on to some state, and it will communicate with other units of computation as well. So in this case, other actors. So you look at it and go like, that sounds like pretty similar to classes in object-oriented programming. So yeah, if you look at it, you can actually compare it to classes in the object-oriented paradigm. But it's a little bit more than that. It's a lot more complexity involved in this. So for one, it always runs in a single thread. So you don't have issues with concurrency. And the way it actually calls other objects, communicates with other objects, is through messages. And these messages are actually immutable, which means that you cannot change these messages when you get them. So that's what the whole thing is based around. So let's jump in and look at the Reliable Actors API itself. Now, what you can actually do with the Reliable Actors API is you can actually build both stateless and stateful objects. We call it a virtual actor programming model, mainly because once you actually have an actor running in the framework, it resides forever. It never actually kind of dies, virtually. So you can actually create an object and it will reside in the system forever. And the programming model actually allows you to automatically store the state, and it also provides that turn-based concurrency I was talking about. I'll touch upon the concurrency bit a little bit later, but think of it as running in single thread all the time. Each and every actor has a unique ID. So if you want to access an actor, so you basically use the ID and then you call that actor. You can think of it, let's say you've got an actor for a book. So if you've got a library and you want to store all the books in it, each and every book will be an actor. And the way you actually access that actor is through its ID. It could be an ISBN number. So you can basically go and say, hey, get me this actor and pass that ISBN number, and it will get you that book object. And then you can actually play around with it. So the service fabric will effectively manage all the nodes, and because it manages the nodes, it'll manage all the actors as well. So it'll actually move those actors around the different nodes if it needs to. If it's running out of space and it wants to persist and get rid of it in memory, it will do all of those things for you. And as I said, each and every method for an actor runs in a turn-based concurrency model. So if you want to get started, first thing that you need to do is to go and download the service fabric. And then once you install it, you'll be able to start up the service fabric, the cluster in your local machine. So you need to also set up like a whole bunch of execution policies to get it up and running. And then there's a script that says dev cluster setup.ps1. If you run it, it'll actually set up that cluster locally. And from then on, you can actually deploy everything to your local cluster, test it, you can put breakpoints on it, do all your testing, and then when you're ready, you can actually move that cluster up to the cloud. Now, if you're deploying directly to the cloud, or if you want to set things up, you can go over to the portal and set it up. Now, all those bits are available in private preview now. And I'll show you a really quick demo of that so you can get a feel for how the user interface and everything looks in the portal itself when you try and set it up. So if you want to create an actor, you first create an interface. It's pretty straightforward. you need to extend this iActor interface, and you can write as many methods as you want. Notice that everything is async over here. So because it's async, it returns a task of string rather than a string itself. The second thing that you need to do is to implement the actor. So you extend the actor class, and then you effectively write your implementation over here. And you implement the interface, extend the actor class, and then that's about it. Pretty straightforward. If you want to call it from a client, you need to access the name for the where the actor resides, or the application itself. So that's the application name. It's got a unique URI over there, fabric:/hello world. And you basically use actorproxy.create and specify the interface that you want to create over there. And you can pass in an ID for that actor, like I said. And then that's pretty much what it is. You just say proxy, and you do doworks async, and you access it like a local method, but in fact, it goes up to the server, executes stuff in the server, and comes back to you with the result. Let's quickly jump in and have a quick look. So once you actually install the SDK, it adds a whole bunch of things in your Visual Studio. You can also go over to, I think I've got PowerShell running somewhere. So you can go to this directory, Program Files, Microsoft SDK Service Fabric, and Cluster Setup, and that's where you have the scripts to run the dev cluster setup.ps1. Once you run it, it's there. It's running all the time. You can connect to it from Visual Studio. You go to your Cloud Explorer, and you can actually see the Service Fabric shows up over here. Now, I've got 5 nodes in my cluster. As I said earlier, it's the same as running 5 VMs, but because I'm running it in a single machine, node not necessarily equal to a VM, but it simulates the environment for you. Okay. I don't have any applications running right now, so I can go in and say File New Project, and notice that it's added a new project type for me called Service Fabric Application. I can go in and say Ignite AU. Notice that it's added 4 templates over there. So I told you we've got stateful and stateless services. And then we have 2 programming models. One is the actor programming model, and the other one is just a reliable service. So it shows those 2, effectively it shows a combination of that equals 4. So let's go ahead and create a stateless actor service first up. So maybe we'll call this calculator actor. So when I do this, it creates about 4 projects for me. One is the project that holds the interface or the interfaces. In my case, it'll just create one interface called iCalculatorActor. And then another class with an implementation for the interface. One for the service that actually runs the actor. And finally, a client project where you can actually test it. So those are the 4 projects over here. The calculator actor, as I mentioned. So this is the interface. I've got the calculator actor over there. This is the project that actually will be running on the server. Notice that all it has is an application manifest file right now. That's the client project, which is where we actually used to call the service. Let's go ahead and change this. So maybe we'll add a couple of methods over here. Let's just call it sum. And we'll just add a couple of methods over there. We'll call this difference maybe. If I go to my calculate actor, notice that it implements the iCalculator actor and it extends the actor class. So let me go ahead and implement those interfaces. I'll get rid of the sum async. It's defined twice. And we'll just do A plus B. This is just the event source will, this is basically for diagnostics purposes more than anything else. And I will copy this, and we have two methods, one for sum and one for the difference. That's right. If I go over to the client over here, I can basically go ahead and so if I have just one service in my application, I can basically do something like this. Used to have an empty constructor. All right. I'll skip that. So I can actually go ahead and rename this actor. Basically, I can say new actor ID and specify calculator. The constructor for the actor ID, it actually can be either a GUID, can be a string, or it can be an integer. So we'll just use a string for now. And let me write this as well. Control should be. Let's do 100, 200, and I'll add another line. Thank goodness for autocomplete, because I've made a typo over there and filled that out as well. So console.read key. So it just stops over there. So what I need to do is, now that I've written it, I can go ahead and deploy this. So if I go over to Ignite AU, I think let me just rebuild this one more time. Control Shift B. I can go in, right click, and say publish. And when I hit publish, that will actually push it into the local cluster that I've actually created. So I go over to Cloud Explorer. You see that there's an application that's actually popped up now, which wasn't existing before. Now let me go over and quickly open up if I go over and look up my application manifest file, this defines the type, the type that have actually been created. So the type of application, see Ignite AU type over here. And it also has the number of partition counts, how many partitions it's actually deployed to. If I specify this as 1 over here and republish this, so notice that it's actually popped up 9 times over here. It's popped up 9 times over here. If I change that partition count to 1 and I publish it again, so you got tight integration within Visual Studio itself. So it allows me to publish it to the cluster, and allows me to put breakpoints in and debug it from the cluster itself. So let's just refresh this. Notice that now there's only one instance of it running. So there's also another tool that Microsoft actually provides. It's called the Service Fabric Explorer. And you can use the Service Fabric Explorer as well. And it sits outside of Visual Studio, so I like to use it sometimes because it's nice and big and all that. So you get exactly the same stuff over here. So notice that it's actually deployed in Node 3. So I have 5 nodes over here, and it's deployed in Node 3. Let's go ahead and run this application now. Go and run the client. Debug, start new instance. And that's the expected result. I mean, it showed up with a result of 300 and minus 100. So that's all good. And effectively, it went over to Node 3, executed it, and it came back. Now, if for some reason Node 3 actually failed, let us stop on this node. And if I refresh this, I should refresh this, sorry. You'll notice that it's changed the node. It's now automatically, because it's realized that, hey, that node is actually down, it takes that object and puts it across in another node, so you can actually use it. So let's start this up again. It'll take a couple of minutes for it to start up, I think. So this is an example of a stateless microservice. So it's almost like akin to having like a static methods in it, right? So you pass all the state across to it. It just does some stuff and it comes back to you. Doesn't hold state by itself. Now, if you want to hold state, what you need to do is, I can actually implement it in the same thing. I can go in and say, add new fabric service. And this time I can actually pick a stateful actor. Maybe we can pick something, an example where we need to store, persist store. Maybe we'll pick up something like a bank account. So it's going to be a very simple implementation. So I'll add a couple of methods in it, or maybe 3 methods. One that actually tells me how much balance I have, and then I'll have something that actually, the method to credit and method to debit. And then we can actually see whether that keeps persisting. And we'll also create more than one actor to basically show that they're all separate objects itself. So a couple of things to point out over here. The first thing is that instead of extending actor, I actually implement actor of T. If I go in and look at this bank account actor, it looks like a WCF, data contract, if you guys remember that. It can also be a serializable class, but this one's got it's auto-generated this class for me, and it's put in a data contract over there. So rather than call it account, let me call this as balance. So let's do that. That's done. And I also want to add a couple of methods into the bank account actor. So first thing is I'm going to go and change this. Let's do get balance. Let's call this get balance. And just for the sake of simplicity, we'll just keep this an int. And let's just do credit. Debit. Let's go ahead and implement this in the bank account actor. make this async. So I'm going to do is this will be credit, and I'll have a debit one as well. Debit async. Sure. That's all right. Let me fix this. Should have done the cut and paste after I fixed it. It's all right. So that I've actually implemented a basic rudimentary accounting class. If I go over to my client over here, let me just go ahead and add a reference to the interface that we just added, which is the bank account actor interface. And I should be able to try this out. So rather than I calculator actor, I'm just going to go with I bank account actor. Let's use my name. So this will be going to be my bank account. So we will actually credit and debit money into that account. And I can basically say proxy dot get balance async. And what I want to do is I want to perform a couple of transactions in it. Proxy dot credit, let's say it's $200, dot wait. So if I run this now, let's just first build it, make sure everything's okay. And yes to all. I'll publish this now. Once I publish this, you should actually see those two services pop up under that application. It's the wrong one. Notice that there are two applications, there are two endpoints that have been popped up, one for the bank account and one for the calculator actor. If I run it now, I should expect $100 added first and then $200 added next, and you should have $300 show up. Now, because it's a stateful service, if I run this again, the value of $300 that is now in my account should actually persist. So when I load it up again and run it up again, it should start with a balance of 300 before I do it. Should have done this. It's all right. Because I hit the run button for the service fabric, let me also show you something. I can put breakpoints in my code. So for example, if I wanted to add if I want to put something on my get balance, I should I should be able to do it while I'm debugging this application. So there you go. So it did break over there, right? So you get a nice seamless debugging experience while you're working on it. Let's do this again. So because the actor was, initially the amount was 300, we actually ran it again, and now the balance is 600 as it's supposed to be. Now, the other thing I want to show you is that is actually a very specific object. I can create another proxy. And can do exactly the same thing for this person. If I run this now, notice that Joe blogs had 0 because it's a completely different entity or different actor, and all the transactions that actually goes to that specific object. So right now there are 2 actors sitting in the cluster. If I go ahead and knock off one of them, another interesting thing that you can actually see over here, it's got 3 of them. I should actually run it in. It's almost impossible to show, so let me do this again. Let me just reduce the number of partitions that we have. I'll just change it to 1, so I can actually quickly shut it down. And still publishing. Just give me a second. Well, once it's finished, I'll be able to run. Okay, there you go. Demo gods are not kind. That's okay. It's still okay. Nothing's crashed, I think, so far. Let me go back to my cluster over here, and maybe what I'll do is I will look at where the bank accounting service is. And I want to show you that now, if you notice, there are 3 nodes in which that runs. One is the node 3 is still the primary, and you have 2 active secondaries. This is effectively what it does. You know, I did tell you that everything is actually stored in local storage and then gets replicated across to other nodes. And that's what's happened. You have only 1 primary node, and then you'll have 2 secondary nodes. So now if something actually happens, and if I, node 3 dies, as it did previously, what will happen is that one of the other secondaries will take over as the primary. So Notice that node 3 has become the idle secondary, and node 1 has been promoted to become the primary itself. If I restart node 3, it'll get promoted to active secondary, but it won't become a primary again. Okay? Notice it's changed over to active secondary over here. Okay? Now, hopefully that's kind of like giving you a little bit of an intro to how reliable actors work. I will switch over to my slide deck. We'll talk a bunch of other things. We'll talk about the life cycle of actors itself. Now, as a number of things actually, as you have more and more actors running in these nodes, they effectively start getting, they start filling up and using up resources and things like that. So one of the things that you may want to do is to persist them and then get rid of them from memory itself. So if an actor, but first, right, what happens when your actor gets created? So remember I actually said, get new proxy and then pass in an actor ID to it. If the actor does not exist with that ID, it actually gets created. If it's there, it'll effectively return that object to me. Okay? Now, if it's not in memory, it'll still create that object, and its state is then loaded. So from the storage, it'll pick up the state, fill up that actor, and it'll send it back to you. There's a method that's called onActivateSync that'll be called as well. So if you want to do some initialization stuff, as soon as your state is loaded, you can do that in that method. You also it gets added to an active actors table. So this is how the service fabric keeps track of which actor is active and which one is not in active and things like deactivated and things like that. So unused actors, if you don't call any methods on the actors for a period of time, that gets deactivated. So the first thing is once it gets deactivated, an onDeactivateSync method will be called on the actor, and this allows you to do something with it. If you wanted to perform an action when the actor is deactivated, you can actually do that. And once deactivated, objects can be garbage collected by the CLR itself. Now there are a couple of things that you can actually control on when you're managing the lifecycle. First one is the scan interval, the time interval between the successive scans. So effectively, this is what the service fabric uses to determine whether how frequently it actually looks whether the actor has been used or not. You also have an idle timeout. The time an actor can be idle before it's effectively deactivated. So those are the defaults over there, which is effectively 60 seconds. You can actually change this to make sure that it resides for a much longer time. And the way you do it, you stick this actor garbage collection attribute on top of the class or the interface, and you can it'll use those properties. So let's talk a little bit about the state management itself for actors. When an actor is actually, whenever you call a method in an actor object, on a stateless on a stateful object, a stateful actor, at the end of the call, that actually gets persisted to the local storage. So at the end of every call, it'll actually get it'll get saved to the local storage, and straight away it'll get replicated across to all the secondaries, all the replicas, as it's called. Now, sometimes you may be thinking, hey, this is a bit of an overkill, because in my example, I had a method that actually says, get me the current balance. When I get the current balance, there is no need to persist that state back into the storage and then basically doing a replication. So in those scenarios, what I need to do is I need to slap this read-only attribute on top of methods that don't actually change the state. Now, there may be another scenario where you may want to write more frequently. So you've got a long method in the actor class, and that does a number of things. And you don't want the state to be lost if something goes wrong in the middle of its execution. So you can explicitly call a method called save state sync that allows you to save the state of the object like while you're doing stuff. So you can also control the durability of the state. I mean, durability as in it gets written to storage. Now, by default, the storage provider is durable, which means that every time you actually change it, the change will not be lost. It will be written to your local storage. If for some reason you say, hey, you know what, I actually don't want to use the local storage. I just want it to stay in memory. And that's probably good enough for a lot of people. Because you think about it, right? You have a primary and you have two secondaries where this data is written to. Rather than actually just store it in, local storage, you can store it in the memory of each and every one of those things. So that way, you can use this volatile actor state provider attribute on top of your class to effectively say that, you know, I'm quite good. You know, you don't have to save it across to storage. It's fine. However, keep in mind that if the whole thing blows up, if all your primaries and your secondaries blow up, then you would have lost all your data. You can also control the number of replicas that you want. By default, we saw that it is 2. You can go ahead and set this up in the configuration file and say I want more than 2 replicas, and you can do that. You can control that as well. You can also customize where a state is stored. So you can build your own custom state provider. So if you think that, you know, I don't want to store the state to local storage, I want to use something like table storage or a document docdb or any of that stuff, you can write your own custom state providers and use it. So I want to talk next about a little bit about concurrency, timers, and reminders. Now, actors use a turn-based concurrency or turn-based threading model. What it actually means is that, let's say you made a call to an actor with a specific object, a specific ID, and it's actually running through stuff. If another object calls this, someone else comes and calls the same actor, that will effectively put on hold until it finishes execution. Once it finishes execution, then it'll give control to the new request that's actually come in. So it runs in a single-threaded model. Now, if you have, let's say, actor A calling actor B, and actor B calling actor A again, then you could potentially have a bit of a deadlock scenario, right? So by default, reentrancy is allowed as long as it runs in the same logical call context. So if the same thread of execution goes in and comes back into the same actor, then it'll allow you to continue. But if it's not from the same logical call context, it'll basically wait. You can sometimes people say, you know, I don't want even that a level of reentry. In those scenarios, you can actually put an attribute with a reentrant on top of that actor, and then you say reentrancy mode .disallowed, and it will prevent that from happening. So when you're testing this application and so on, you basically know that you're not getting any reentrancy at all. You also have 2 other things called timers and reminders. Timers are effectively what it is. I mean, if you want to call a certain method in your actor at a frequent intervals, you can set up a timer and it will make those calls frequently. They do respect turn-based concurrency. So if the actor is actually executing something in between and the timer makes a call, that will actually be put on hold until that actually finishes execution. Now, one of the key things to remember, though, that if the actor is not active anymore, then timers don't work. So you can kind of like get around this problem by, remember that I actually showed you that you can change the idle timeout. If you basically set it to a much higher value, then that may not happen. but that's something to be aware of. So that's the code that you do. You effectively do a register callback, and that's the method, the actor method that actually gets called within the time interval. That sets you the time interval, and you also pass a state to it. That's the parameter that gets passed across to the actor method that you actually call. You also have reminders. Reminders are used to. It's very similar to callbacks, but it used to fire persistent callbacks on the actors at a specified time. And the key thing over here is that, unlike timers, even if the actor is not active anymore, it will still call it. So to implement it, you need to implement an interface called iRemindable, and that's how you do it. I want to quickly run through the Reliable Services API, which is effectively the other way of writing services. So the key thing over here is, you write services that are effectively very similar to microservices. Very similar to actors, but you use a communication technology of your choice. So remember, we had that little URL, that URI that actually said, was it Fabric? And then you had that slash and everything else on it. You can expose your services through WCF or Web API or whatever it is that you want to do. And one of the things that it actually implements is this concept of a reliable collection. So what you do with reliable collections is, if you look in .NET itself, I mean, you have just regular collections, which is dictionaries and queues or whatever it may be. And then you had a next level in .NET, which were concurrent collections. Now, with reliable collections, the collections become durable as well. So when you write an item to a dictionary, a reliable dictionary, it will persist it to disk so that you have it available all the time. So unlike going over to Azure queues or something like that, you can use this to persist a collection of data. So the key things over here is it is persistent, basically durable, and the same thing like in the actors, right? They're replicated, so you have multiple copies of that running as well, and you can run it across multiple machines, and they are asynchronous, and you can run it in a transaction. So if you have 2 or 3 operations that you want to do on a collection, you can run it within a transaction. So to get started, all you need to do is you go through the same rigmarole of going to Visual Studio and then saying new service, and I'll actually quickly show you. You effectively get 2 methods in the service. So with a stateless service, for example, class, you got to implement this iCommunicationListener and a run async method. The create communication listener method will return an iCommunicationListener, which is effectively, you can say, you can write a WCF listener. So this is the method that actually says, hey, I want to be listening in on a certain class. I'm expecting some input and so on. Whereas the run async effectively is like your run method in your worker role. So that runs forever, and you can actually do stuff with it. That's how we use a reliable collection. So you create a reliable dictionary in this case. Notice that I put everything in a transaction. I can do multiple adds or updates to that dictionary. And then you can effectively commit it. Quickly go through a demo of that, and then I want to show you a real quick demo of the portal as well. This is going to be a very quick demo. I'm not going to go through a whole lot of stuff. I can create a stateless or a stateful service. Go ahead and create it, much the same way as we did with the actor services. As I said earlier, the main difference over here is is the create communication listener over here. You implement the communication listener if you want, let's say if you want to expose a WCF endpoint, this is where you do it. If you want to run things like a worker role, you go ahead and run it in the run async. So let me see if I can go in and so last thing I wanted to show you was effectively the portal. And I've lost the URL for it. Just give me a second while I... So if I want to create a new service fabric from the portal, click new. Eventually what will happen is that will show up in somewhere in compute. Right now it doesn't show on compute. You got to go to the marketplace and search for it. So I can go search for fabric. I see the service fabric cluster. If I click on that, it actually could create one. So I can give a cluster name. Let's say Ignite AU. There you go. So effectively, you do a bunch of configurations over here. You can specify what type of nodes you want. Right now, they allow you only up to about 3 sets of nodes in the preview. But eventually, you should be able to set up any number of nodes. Now, one of the key things to remember over here is that each and every node can have its own VM size. So you can have it can be a large node or a small node and things like that. So, so this is what you can basically configure and say, hey, I want 3 nodes, and each and every one of those nodes can be like a medium and a large and a standard. You can set up all those things over here. You can pick the type of VM that you want. I've got something pre-configured over here. Go to Service Fabric Cluster. It doesn't have anything implemented. But notice that it's got 5 nodes over here, and effectively this is the same. It's the same cluster that you actually created with your PowerShell script, but it's actually running on Azure. So I did that. Just quickly want to wrap up. I mean, effectively, Service Fabric is the next generation of PaaS that you can use to create microservices. I mean, you can go ahead and create microservices now, but what this does is it takes care of all the underlying cross-cutting concerns, things like availability and reliability and all those kind of things it actually takes care of. Particularly if you want to write stateful microservices, it allows you to persist the data into local storage, and you don't have to worry about how you go about persisting data at all. Like I said, it's got 2 programming models. One is the Reliable Actor API, and the other one is the Reliable Service API. We covered most of the Reliable Actor API today, but the Service API can also be used to create services, microservices. But they are all about exposing endpoints to WCF, and if you want to write or web API and things like that, you use it. It also provides things like reliable collections that you can actually use. Effectively, what the Service Fabric does, it takes care of all these things: availability, scalability, and load balancing, and all of that kind of stuff. So that's all I had. Please complete your evals, and if you've got any questions, I'll take questions now. Yeah?
With the stateful storing of data, with the default local storage, whether that actually is like, what kind of performance do you get out of that?
So because your data is stored very close to your compute, effectively it's in the same drive, same machine. You lose all the network latency and so on. So the performance is actually pretty good. And if you're using solid-state devices and things like that on those VMs, it's going to be even faster.
Is it like indexed retrieval and things like that?
Yeah. It's all key value store, and they've kind of like optimized that so it stores and retrieves the data pretty quickly. Anything else? Yep.
Is there a one-to-one relationship between a node and a VM?
In the cloud, yes. Whereas when you're running it on your machine, it doesn't.
So if I normally have something running on a VM and I want this resilient architecture,
Yeah.
3 nodes and a minimum of primary.
Yeah.
So
Microsoft actually recommends 5 machines, and the reason for that is that when they do upgrades and things like that, so they need to make sure that they do it appropriately. So they recommend at least 5. If you had only 3, then it's a bit of a problem. So they recommend at least 5 to start with. All right. Yep. One more question.
Apologies if you've covered this, but it runs in a sandbox. What are the limitations of the kind of functionality that you can implement in the microservice environment?
So what the question was, what are the limitations when you're implementing it on a sandbox?
Well, presumably it runs in in a sandbox environment.
Yep.
So what are the limitations?
Yeah. So so there are certain things like what ports that are allowed and so on that you need to configure. So you do have certain restrictions on that. But effectively, whatever access to other external services and all that is still available to you. So if you want to write something if you want to access a SQL database, for instance, you should be able to do it. It's not restricted to that cluster alone. Yeah. Cool. If you don't have any other questions, let's call it a wrap. Thanks, guys.